Hey guys, so we just wrapped up, factoring trinomials. And now we're going to go, whoops, I just randomly put a line on the page, it's fine. We're going to go to kind of the next topic, which is going to be on page 10. And again, we are so shocked by the fact that there is a page number here. Let's go. Anyway, so we're going to say factoring again. And then we're going to say difference of squares. We're feeling lazy, so we're actually going to put a square as a picture rather than take the time to write it out, because let's face it, we've been working hard lately. So our essential question, what I want you thinking about is what are the requirements? And we'll definitely get those figured out. So we're going to talk through some difference of squares. In difference of squares, the square part stands for, this works out so well, perfect squares. So really quickly, let's talk about what perfect squares are. Remember, a perfect square means a number times itself. So for example, 1 squared is just 1 times 1, which is just 1. Now we're not going to do that for every single one, right? In fact, we don't even really need it for this one. But that's where it's coming from. So 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 squared is 81. 10 squared is 100. 11 squared is 121. And 12 squared is 144. Now we may need to pause here for a second so you can get all those written down. And then, and even more so, I'm going to show you another place you can find them. So obviously, right here, you can write them all in here. You can also, and if you've got a highlighter, bust it out. Because on our multiplication table, whoa, it's the cover. On our multiplication table, I'm sure you got there much faster than I am. You can see a couple things. Mine are already highlighted, but yours, because it probably didn't color copy, you might want to give it a good little highlighter touch here and give it a little extra love so you can see those perfect squares. They're also right here. My dog's sleeping in the room. And on the other side, we have some perfect squares in terms of variables, and those will come in handy shortly. So you might want to call attention to some of those things on that page. But back to page 10. Back to page 10 of your note packet. So our method is basically just difference of squares. In other words, difference meaning we are subtracting. Squares, of course, referring to those perfect squares. Right? Here's what we're going to do. Here's our steps. First step. First of all, this only works if we have 2 terms. If we have 3 terms, 3 terms, use the x, which I know you guys are fabulous at. Step 2. Check difference. In other words, are you subtracting? If not, just stop. And then if you are subtracting, check for squares. Because if you have squares, then you can do the next thing. So if you're good, write your parentheses. And what you'll do is you'll fill your parentheses using the square roots. So here's an example. Let's say we had x squared minus 16. Do we have 2 terms? Yep. Do we have subtraction? Yep. Do we have squares? X squared is definitely a perfect square. 16 is also a perfect square. So in this first one, x squared is x times x, and 16 is 4 times 4. And so we definitely have squares here. So then we're good, so we're gonna write our parentheses. And in those parentheses is gonna be a plus and a minus. It'll be plus, minus, and then these blue things that we kind of wrote on top, that's how we're gonna fill it in. So we're gonna do x plus, x minus, and then 4 with a 4. Okay, so let's look at a couple examples. Here's our first one, x squared, y squared. So do we have 2? Yep. Are we doing subtracting? Yep. Do we have squares? Yep. The first one is x times x. The second one is y times y. So let's fill our parentheses with the plus and the minus. X times x is x, and then y is in the second spot. Well, she's not sleeping anymore, and I've kicked her out of the room, so we should be good. Anyway, here we go. And the next one, number 2. Let's check it. Do we have 2 things? Yep. The first one is the 49x squared. The second one is the 36. So we have 2 separate parts. Are we subtracting? Yep. Do we have perfect squares? Well, 49 is 7 times 7. X squared is x times x. And 36 is 6 times 6. So we do. Here's what we're going to do. We're going to set up our parentheses. Parenthesis it up with a plus and a minus. Before the plus, we're going to use the 49, x squared. So that's going to be a 7 with an x and a 7 with an x. And then after the plus and after the minus, we're going to go 6 and 6. Okay. We've got 2 more here, so let's do those real quick. We've got the next one we see. Do we have 2? Yep. Are we subtracting? Yep. Are they perfect squares? Yes. 4 is 2 times 2. X squared is x times x. 25 is 5 times 5. So we can build our parentheses with a plus and a minus. It'll be 2 with an x and 2 with an x. And then 25 is 5 times 5. Let's do this next one. I will not keep making the checklist, but it's kind of fun. And it's a good reminder of what do I need? Remember, that was our essential question. What are the requirements to be able to factor this way? Do we have 2 things? Yes. Are we subtracting? Yes. Do we have squares? Yes. 9 is 3 times 3. X to the 6th. If we think back to our stuff from page 3, our mult table, we highlighted that x times 3 and x times 3 made x to the 6th that was in that box up at the top. So we're good here because x to the 6th is x3 and x3, and then 16 is 4 times 4. So we can build our parentheses. I'm going to build them a little bit bigger this time because I want 3x to the 3rd and 3x to the 3rd, and then 4 and 4. Okay. Here's what I want to do. I want to do just the first two on the next page, and then we'll save some of the others for a different time. And since we're only going to do two, we'll totally checklist it up. So do we have two things? Are we subtracting? And are they squares? Do we have two things? Are we subtracting? And are they squares? Okay. In the first one, do we have two things? Yes. Are they subtracting? Yes. Are they perfect squares? Yes. We've got an n times an n and a 1 times a 1. Kind of boring, but still good. We're going to have n plus 1 and minus 1. So it looks similar, but it's not exactly the same. And that's cool too. Okay. Let's check the next one. Do we have two things? We do. Are we subtracting? No. Bummer. Shoot. We are not subtracting. Which all that means is it doesn't factor. So we just stop. We can't do anymore. Oh, number 5 is such a good question. Oh, we'll save that one. We'll save that one for I get to see you guys again because I love that one so much, and so we're going to save this. In the meantime, you get after it on your assignment and remember your checklist. What are the requirements? We can totally answer that now, right? We need two things that are subtracting that are perfect squares. So in our summary spot, we need two perfect squares being subtracted. I know that I switched the order compared to our checklist, but that's okay. It's not a long summary. You might want to add a little bit more about what a perfect square is or what we mean by subtraction or why this is so important, but that is what we've got going on here. Okay? Get after it. I believe in you. You can do this.